ammonium ion. Ammonium ion has a formula NH4 plus, where the nitrogen here, nitrogen has atomic number 7, so that means there are 5 valence electrons. 1 is here, 2 is here, 3 is here, 4 is here. It has, this is a typical structure of nitrogen, where you have 5 electrons surrounding it. The hydrogen you have here are 4. The first hydrogen carries 1 electron. The second one carries 1 electron. The third one carries 1 electron. The last one has no electron. So this electron comes to pair up with this for the first case. This electron comes to pair up with this for the second case. This electron comes to pair up with this for the third case. The last hydrogen is deficient of electron. That means for a combination to exist here, this chlorine, nitrogen has to donate the pair to the deficient hydrogen that is coming with no electron. And to justify that, you have to denote it with a positive charge to show that it is having no electron. And if you look at this scenario, you will see that the 2 electrons here are being donated by nitrogen. So that means this hydrogen has no electron to donate into the system. So this is a typical example of a coordinate covalent bond, and it can also be called dative bond. Metallic bond. In this bond, these electrons move among the atoms in the metal and are shared by all the atoms in the metal. Examples: the bonds between 2 atoms of sodium and lithium. Here, sodium is a metal. Lithium is also a metal, and they have one electron in the outermost shell. So before a bond can exist between them, this one has to contribute its electron and this one has to contribute its electron. And since they are both metal, then the bond that is formed between them is known as what? Metallic bond, because they are both metals. Note, the 4 types of bond listed above are strong bonds. Let's talk about weak bonds. Examples of weak bonds are the bonds that exist between hydrogen, known as hydrogen bond. The second one is what is referred to as van der Waals forces. What is hydrogen bond? Hydrogen bond, this is the bond between hydrogen and a highly electronegative element. Examples are bonds in hydrogen fluoride. Also, bond in ethanol. Hydrogen fluoride. Hydrogen and a highly electronegative element. Here, the bond that exists between this hydrogen and a highly electronegative element is known as hydrogen bond. Van der Waals forces. What are van der Waals forces? These are weak attractive forces which exist between discrete molecules. Examples are in iodine, naphthalene, camphor, etc. Iodine exists like this. So the bond that exists between these two iodine atoms is regarded as van der Waals forces. It is a very weak force. That is why it is termed van der Waals forces. Nomenclature of compounds. The most widely recognized method of naming compound is the use of International Union of Pure and Applied Chemistry, known as IUPAC. Examples: if you are to name the following compounds, this is the first compound, this is the second compound, this is the third compound, and this is the last compound. To name this first one, you calculate the oxidation number of chlorine here. Since sodium is a group 1 element, it has 1 electron plus 1. Chlorine that you have to calculate is unknown. Assume that is chlorine. Oxygen has a valency of -2. -2 times 3 gives -6. And everything, algebraic sum of everything that you have here is equivalent to 0. By mathematics, +1 minus 6 is equivalent to -5. Chlorine minus 5 equals to 0. To calculate the oxidation number of chlorine here, you collect like terms where chlorine will now be +5. So that means if you are to name this compound, this will simply be regarded as, you name this first. Na is sodium. Sodium. You have 3 atoms of oxygen. In chemistry, it is called tri. Because it is oxygen, oxo, then you call it trioxo. Trioxo. Chlorine that you have here in the midst of this compound, it is known as chlorate. But since you have the valence or the oxidation number to be +5, then automatically it will be sodium trioxochlorate 5. So the name of this compound is sodium trioxochlorate 5. The second one here is copper sulfate with 5 moles of water. This 5 moles of water is called penta, because you have in chemistry 5 is pent, and because this is water here, you call it hydrate. So this is pentahydrate. Now sulfur here, copper has +2. Sulfur is what you want to calculate. You do not know, but you know that oxygen is -2. -2 times 4, that makes -8. equals to 0. Plus 2 minus 8, that gives minus 6. Sulfur minus 6 equals to 0. Therefore, sulfur will now be plus 6 by collecting like terms. So if you are to name this compound, it will be, you name this first. Cu is copper. Copper, how many oxygen do you have here? 4. So in chemistry, 4 is regarded as tetra. So copper 2, because of the 2 oxidation states of copper. Copper 2, because of the 4 moles of oxygen here, tetra. Copper 2, tetra, oxo. Sulfur in a compound is called sulfate. So sulfate. Sulfate, what is the oxidation number of copper of this sulfur in this compound? It is plus 6, as we calculated earlier. So that makes it copper 2 tetraoxosulfate 6. How many atoms of water do you have here? 5. And I've told you earlier that it is penta. So because it is water, you will say pentahydrate. Then this last one, they are known as organic compound. 2-methyl-butan-2-ol will be explained better in organic chemistry, but the structure of this compound is butan-2-ol. Butan-2-ol is 4 carbon